Welcome to the Hydraulic Press channel. Now, welcome to the statistician. In today's lecture we are going to look at the frequencies of data. Okay. We start by creating random data. Well, we could use pre-built data of R, but I'd like to show you some nice package called FakeField, and you can download it by writing this and this, or just Google it for information. And you can create quite realistic data with the FakeField package. I will show you. If you want to repeat the data, use same seed number as I'm using. So the function of this package is RDataFrame, and you have many variables that you can create, and the list is quite big, but for this example I will use a sample of 500 observations. Then I will have an ID variable and sex, and then the age that has a range from 20 to 80, and then two categorical variables, religion and education, and lastly I will have a IQ variable, and the mean is well known 100, and standard deviation is 10. Okay, and we will use this function inside a data frame because for some reason our data frame creates data with the 3 classes instead of plain data frame. Okay, and next we will look at the categorical variables. We'll use sapply function for columns that are is factor, and we will then print the levels of these columns that are factor variables, and we will see that there are quite a few levels for both religion and the education. And next we will print some descriptives, and we will use Psych package, and you can install it if you don't have it. And I like the describe function of the Psych package, and again we will use the sapply function, and we will check if the column is numeric, and then use the describe function. We will see that for the IQ the mean is quite close to 100 and the standard deviation is quite close to 10. And I'm using transpose function just to squeeze the data to this slide. Next we are doing some contingency tables, and I'm using the with data syntax, but you can use the $sign syntax, and we can see that using table function we will have the sums of each religion divided by the sex variable, and we can see that there are no Jewish female in this data. All right, and we can enclose this syntax with the add margins, and this will print the sum of row sum and the column sum, and we can see that there are 500 observations, and the Christians are the biggest group after, well, it's quite realistic, I think, for the American demographics, but all right, so we can also convert these contingency tables to proportions, and by using prop table we can see the proportion of Christians. It's nearly the third of all religious groups, and we can also use add margins, and we can see the the same data, the same proportions, but divided by the sex. So in this case we can see that there are more well, the male seem to be more religious than female. Right. No. In fact, let's see. Okay, here we have I have used percentage, and it's easy. You can just multiply the prop table by 100, and then I have rounded, so I have no decimal numbers, so it's the Christians are 32%, consist 32% of this data. And you can also, I'm just showing, you don't have to do this, but you can create a data frame from this table, and I have also used paste function to just for putting the percentage sign after the share. Okay, so yes, we can see that males are usually the bigger group in each domination, except for others. And well, after using paste, you cannot then calculate mean or anything, because these are now characters instead of numbers, numeric variables. All right, and we can also have a three-way contingency table, but because there are so many levels in our variables, I'm just using some of the levels. So I'm using the subset function, and I create a new data frame. And first I will select the data, and then I'm selecting by which variables the new data frame will be formed. So I will have education, either bachelor degree or master's degree, and the data will also include religion only if it's Christian or Muslim. And after this you have to use drop levels. Either if you don't have the drop levels, the empty levels will haunt in your new data. You don't want that. So get rid of the empty levels with drop levels, and then I'm having the syntax with now three variables: sex, education, and religion. And we can see that inside Christians men there seem to be more men that have master's degree, but within Muslims I see that there isn't such a difference. We could test whether the male proportion of a master's degree is significant against the female proportion, but let's do that in some other lecture. Okay, and we can also do some Boolean tables. For example, we can set a table that tests whether the IQ variable is over 120, and it will print the numbers of false and true observations, and there are 10 individuals who have a bigger IQ than this, and then we can also check within the sex if there's a moron by 1928 classification. So in other words, one who has IQ below 74, and there is only one guy, and let's identify this guy, and we will just write our data and the row which have a Boolean argument, and all columns are selected, and it's a ID number 435. It's a old Muslim who has an IQ of 73, but still have a regular high school diploma. But I don't know if the IQ is correlated with the education in this random data. Maybe not. Okay. Thanks for watching. I hope this helps you.